right. Hello everyone. My name is Song Park. I'm in technical support team. I'm a structural engineer. So thanks for coming today's training session. This training session is last training session in 2015. So our technical support team will have more training session in 2016. And also after this training session, if you have any question, just let us know. Send us an email like a ts@midasuser.com or send me email swpark@midasuser.com. So today's training session is design check and load rating. Before starting our training session, I want to go over what I'm going to talk about today. So the first, I'm going to talk about the modeling and design check. But beforehand, I want to check, can you guys hear my voice very well? Or should I speak up? All right. Give me a second. Can you guys hear me well? All right, perfect. I can see many yeses. All right. So today, I'm going to very focus on design check and load ratings. So, but I'm going to open up the one model because we need an example. But beforehand, so far when we are talking about the modeling informations, defining section and material properties and geometry of bridge, we were very focused on the difficulty of the geometry of bridge, such as straight, highly skewed, highly curved, or how to connect the substructure and superstructure by using elastic link or rigid link. But today we are not going to cover those details because we are going to do like a design check. But I want to put emphasis on the fact that modeling information is very important since design check is performed based on the modeling informations. As you know, when you are modeling a bridge, you're going to create a new sections and material properties, and you might have the some like your own cross sections, such as composite steel gutter sections. So from there, when we are doing the design check, those based on those top flange and web flange thickness, you're gonna get the moment of inertia and section modulus. Those things are already ready for design check. So that's why I'm going to talk about the modeling information and how the modeling information influence design check. And then I will talk about the more parameters for design check and load ratings. So after you create a bridge model, and you're gonna take a few steps, such as definition of moving load cases and load combinations. After that, you're gonna go to design check tab, and you're gonna define the more parameters such as lateral torsional buckling, or like a shear stiffener or longitudinal reinforcement, so on. And then I will talk about the design check and load ratings. So load rating is, based on design check because AASHTO LLFR, when you review the AASHTO LLFR, you might refer to AASHTO LLFD a lot. So there is some interaction between the design check and load ratings. That's why I'm going to talk about the design check and load rating together. And finally, I will just go over the load rating as well. So basically, today's model example is a steel composite bridge. So I created this bridge by using the steel composite bridge widget. I want to talk about the why you have to use a steel composite bridge widget when you're doing the steel composite bridge modeling. Because first, it takes shortened times compared to other methods such as creating node and element over than 1,000 node and element. Using the steel composite bridge widget is much better than just using the node and element approach. And in terms of steel composite bridge widget, in terms of like a geometry, steel composite bridge widget cover the straight, covered, and multi-curve. Most types of geometry can be covered in steel composite bridge widget. And next one is automatic link connections. So once you create your bridge through the steel composite bridge widget, you don't really need to consider the link connections such as elastic link or rigid link. It's automatically connected through the steel composite bridge widget. And then construction stages. So construction stages are very important while you're doing the design check, because you need to know the composite actions before composite or after composite to consider the constructionability. So those construction stages are also, are provided in steel composite bridge widget. So those are like 4 important elements already, built built, and you can create your bridge model through the widget. That's why most of our users have used the steel composite bridge widget. So and also today's modeling example is a steel composite bridge by using the steel composite bridge widget. So more specifically, what informations, what modeling informations, for the design check and load ratings are. First, when you create a bridge, you have the geometry, like a layout and section and material property in primary structures, such as steel girder and cross frames. So those are already in there, and when you're doing the design check in terms of flexure strength limit, you might find the nominal strength. So all the like dimensions for the sections, it's already in there, so you don't really need to define one time more when you're doing the design check. And also in terms of dead load, such as barriers or median strips, so secondary structures expressed by dead load. So like those are already defined in steel composite bridge widget, so you don't really need to define it when you're doing the design check. And also, like you can simulate the composite actions according to the construction stages. So like a construction stage is already in the modeling informations. So Mitre Civil automatically consider all the like before composite and after composite stages of the sections. So once you set up those parameters in modeling informations, you don't really need to define one more time when you're doing the design check. That's why when you do the design check, and when you define the design check parameters, you have only like 7 or 8 options to accomplish the design check, and also load rating as well. So first of all, I just talk about the what modeling information contained for design check. So let me switch to the Mitre Civil, and let me show you the let me demonstrate what I have talked right now. So this bridge model is a straight steel composite bridge today. So as you can see on here, there are like a cross frame underneath of the deck, and here is the substructures, and here is the superstructures. So first over, let me just talk about the steel composite girders sections first. So when you double click the section positive, those are under positive moment. That's why I named it like a section positive. And the second girder section is section negative because it is under negative moment. So when you go to girder section property, you can see those dimensions, like a slab effective width and thickness, and a top flange width and a thickness, web thickness, and bottom flange width and thickness. And when you click the show calculation result at the bottom, you can see those like areas and a moment of inertia and a section modulus already calculated in here. And you can see on here, this first column, it expressed the like a P4 composite, which means is a P4 deck is pulled on the steel girders. And when you see the value after, it is after composite. And those, like numbers already in here. And as you know, those numbers will be used when you're doing the design check by Midas Civil. And in terms of the construction stages, at the stage 1, only substructure is activated. And on stage 2, as you can see, steel girders and cross frames are activated. And stage 3-1, you can see wet concrete load is applied on here. So once you create your bridge model through the wizard, you don't really need to consider or define the more construction stages for your design check. So all the information is already categorized for the flexural strength limit or shear strength limit. So those are those information already in the modeling informations. So from now on, I'm going to talk about the. Give me a second. What else on it for the live load case definition and load combinations. So beforehand, I want to talk about the flexural strengths and shear strengths cannot be fully determined from the modeling informations because when you are calculating flexural strengths of the girder sections, you might need more information such as like umbrace length to consider the lateral torsional buckling, and also when you use transverse stiffener, I mean the shear stiffeners, it will increase the shear capacity. And also when the composite section, when you are considering the composite sections, you might want to put the shear connectors. All those other parameters will be defined when you're doing the design check setups. But so in modeling information, you have the very basic and a very basic stepping stone in there. But when you're doing the design check setups, your design check is completed. So after you create a bridge model, you have to define the moving load case definitions. I know some of you guys have used the steel composite bridge widget. So in widget, you can define the live load, but in a live load definition in steel composite bridge widget, you can only define the vehicle information and the traffic line lanes. So outside of widget, you have to define the moving load case, and then you're gonna create a load combinations per AASHTO LRFD. The next thing is other parameters. As I mentioned before, in order to consider the lateral torsional buckling, you have to define the umbrace length and the shear stiffeners and curved bridge info. If your bridge is curved bridge, you have to tell the program what is the radius of your curved bridge. And also, when you have the negative moment, under negative moment region, the sections will have the tensional stress at the top portions. In that case, you have to define the longitudinal reinforcement. So those parameters will be defined while you are doing the design check setups. So first of all, let me talk about the live load creations. So as I mentioned before, traffic line lanes already defined it in steel composite bridge widget. And also, if you are wondering how to define the traffic line lanes, you can just review the other training sessions before. And also steel composite bridge widget, you can define the vehicle definitions. In design practice, you're going to use your HM93 trucks or HM93 tandems. And when you're doing the load ratings, you're going to use a permit trucks. And then finally, you're going to define the moving load cases on your own. So let me demonstrate this one and what types of vehicles we have in Midas Civils. So from here, when you want to define the moving load cases, go to Load tab and go to Moving Load. And you can see the moving load code first you might want to choose AASHTO LRFD on here, and so here I already defined the traffic line lanes on here, and you can visualize your traffic line lane on model view on here. When you go to tree menu, and you can find a moving load analysis, and you can find the traffic line lanes. Double click this one, and here is a traffic line lane information in here. And right click and click the display. You can see where your traffic line lane is located on the deck. And the vehicles, I already defined the design truck, two design trucks. The first one is HL93 tandem, and the second one is HL93 trucks. So once you go to add standard, this one is our library. We have the bunch of vehicle information in our library. As you can see, when you follow the AASHTO LLFD, you have the design trucks, HL93 trucks, HL93 tandems. And if you're doing the load rating, you might want to use permit trucks, right? So here also we have the AASHTO types permit trucks. But also here you can find different like a DOT's load information on here. But more importantly, if you cannot find your like design trucks or your own permit trucks in our library, you can also define your own trucks at the add user defined it. Click this one, and as you can see on here, truck and lane is for the design trucks because you can define the lane load at the same time. But the permit truck, you can also define your own permit truck on here. And about the moving load case, you can see on here, I already defined the moving load case. As you can see here, you can modify the multiple presence factors. And here, one moving load case, you can have the multiple subload cases according to your design trucks. So at the very bottom, you can find an add button on here. Click add, and you can find the vehicle class. So you can choose HL93 tandems, and then you can find the maximum number of loaded lanes on here. If your lane is 2, you can enter the 2 on here. And you don't forget you have to move this lane information onto the selected lanes. And click OK. You can find the 3 subload cases on here. But today I'm going to use design trucks, a tandem, HL93 tandem, and an HL93 trucks. So we create a bridge model, and there is a lot of information in modeling information, and then we define the live load. Traffic line lanes and vehicles already defined in steel composite bridge widget, and then outside of the steel composite bridge widget, you can define your own moving load case. So I just show you the define the moving load case for design check practice, but you can also define the moving load case for your load rating case. The next step is you have to create your own load combinations. But in MIDA Civil, we provide auto generation per AASHTO LRFD 12. So here is the this one is a load combination dialog box. Let me switch to the MIDA Civil and show you how to create your load combinations. So after you define the moving load case, and go to Wizard tab, and you can find the load combination on here, right? So beforehand, this design check is for girder sections, but also in MIDA Civil you can do the design check for the steel, the cross frame. So this one also can be possibly defined it as a auto generation on here. So once you click the auto generation at the bottom, you can see this dialog box, and tell the program what types of load, the design code are you going to use. So today I'm going to use a AASHTO LLFD12, and you can see the load vectors at here, right? So here we provide three cases. If you wanna use for these as a maximum load vectors, you can just choose this one. And if you wanna just select the minimum load vectors, you can choose min, like a 0.9, 0.09. And if you wanna generate the both of cases, you can just select the both on here. But today I only use the max. And again, this one is for the cross frame design check. So let me just briefly go over how you can check your cross frame design check. So here, once you set up those parameters and click OK, you can see those load combinations. So also you can change the scale factors on here, because if you use if you have distribution factors, you can just apply your distribution factors on here for the moving load case. I mean the live load. So from now on, I'm going to show you how to do the cross frame design check. So that is under design tab, and you can see the steel design. And here steel code is AASHTO LLFD12. And those like a strength reduction factors, you can just modify it by yourself, or you can just follow the AASHTO LLFD12 code. And you can also define the steel material in here, but you already defined your steel material properties before, so you don't really need to touch down this dialog box. And then at the bottom, you can see the steel code check, right? So click this one, and MyDaSi will automatically do the design check for you on here. And if you want to see more detailed information about the cross frame steel design check, you can check on this box and click the graphic at the very bottom. You can see those design reports on here. So from here, let me give you one example, because we also in steel design check, we also have the optimized steel material property functions. So as you can see on here, if you don't like this steel material properties or steel section property, if you think this one is so small to satisfy your design check, you can check on this box and click change, and you can see this dialog box, and you can click the search satisfied section. You can MyDaSi will provide some optimized steel sections for you. And you can change this box, you can change to other sections, and apply that onto your model, and you can redo the design check, and you can get this informations from there. So like a steel design check, you can do the optimized steel section property functions, and also you can get the steel design check report from here at the very bottom. When you click the graphic, you can get the checking result on here, and here also provide why this one is okay. All those equations is ready for you. And then we also provide a pier cap design and pier column designs. So once you put the steel reinforcement in the steel pier columns or pier cap, or if you put the post tensioning tendon, you can do the design check. So you have beforehand you have to create your like a load combinations on here under concrete design tab, and then when the analysis design check as same as the steel design code check, you can get the result values. But today we have interest in the gutter section design check. So this one is the same way. You can go to like auto generation, click auto generation icon, and tell the program what types of design code are you going to use, and which load factor are you going to use, max, mean, or both. So I already created those load combinations on here. So far we created a bridge model and a live load. We define the live load case, and then we create a load combinations per AASHTO LRF D12. So next one is we have to define the more parameters to accomplish the design check. So the first thing is design materials. So in this design material dialog box, you can define the hybrid factors. When you have the different steel material property, steel plate gutter material property at the top flange, web, or bottom flange, you can tell the program top flange is I'm going to use this steel material property, and a web I'm going to use this steel material properties. And MyDaSieve will automatically calculate the hybrid factors for you. And also in design material dialog box, you can tell the program what types of rebar material property are you going to use. Are you going to use a grade C6 6000 or C 4000, so on. And also you can define the longitudinal reinforcement in order to consider the tensional stress when the sections are under negative moment. And shear stiffeners and umbrace length, and shear connectors, and fatigue parameters, and curved bridge informations. So if you define those 7 parameters, you can accomplish the design check. So let me go over this one, those like parameters one by one. So when you're doing the when you do the design check setups, you have to go to design tab, and you can find the composite design. This one is for the steel composite bridge, only for the gutter sections. But as I mentioned before, you can do the design check for the cross frame and pier cap and pier columns as well. So once you click the design material, you can see this dialog box. So here, click the gutter sections, gutter material property on here, and check on the hybrid factors in order to consider the hybrid factors. And you can find a dot box on here. Click this box, and you can tell the program which steel grade are you going to use for the top flange and bottom flange and web. Also at the very bottom, you can find like reinforcement sections. So you can tell the program what steel grade are you going to use for the steel reinforcement. So if you have the grade 60, you can tell the program grade 60, and for the grade of sub rebar, if you want to use the 50, you can just tell the program just grade 50 on here. So how you can define the longitudinal reinforcement? In other words, how you can put the steel rebar on the slab portions. So again, this one is for to resist the tensional stress around the slab portion under negative moment. Steel rebar info is added onto slab. So as you can see on here, around the support area, you can find the negative moment. and the concrete cannot resist to the tensional stress, so you have to put the steel reinforcement at the slab portions. So this one can be found at the longitudinal reinforcement. Click this longitudinal reinforcement icon, and I already separate the sections. The first one is a section under positive moment, and the second one is a section for negative moment. And click the section negative moment, and from here you can see the slab portion. This like a box is a slab. So this one is effective width, and this one is thickness. And on your right hand side, you can find the like a reference line and reference line Y and reference line Z. So you just tell the program, what is the like a clearance for this steel reinforcement by on the reference Y and Z, and you're gonna tell the program how many reinforcement are you gonna use on here, and what is the spacing between the rebar, and you can tell the program what is the diameter, is it number 3 or number 4, and part 2. This part means generally in my civil, when you see the part 2, this one is concrete section, and part 1 is steel sections. And once you define all those parameters and click add and hit apply, you can see those steel rebar reinforcement, steel rebar on here. And the good thing about the this dialog box is once you define the this steel reinforcement information on the slab portions, you can copy this information to the other sections. So in here we have only one like a like a negative moment sections, but if you have a 3 or 4 spans, you might have a different, you might have a more like a sections under negative moment regions. In that case, at the very bottom, you can find a copy reinforcement to button or like icon on here. Click this icon, and like move the your like section to the selected section list, and then click OK. You can find all the like steel reinforcement information is copied to the other selected section. I mean the sections under like selected section list. And next one is a shear stiffeners. In other words, it is a transverse stiffener. So you can add a transverse stiffener to either just one side of the web or both sides. And in Mitre Civil, we provide a shape such as T and flat. So you can see on here, the first case is if you want to put the transverse stiffener on both sides, you can do that in Mitre Civil. And also if you want to put the just shear stiffener on one side, you can also do that. Let me just demonstrate this part, switching to the Mitre Civil. So you can find a transverse stiffener on here, right? Click this one. And also you can find the section positive and section negative again. So check on this box, you can find a transverse stiffener on here. Check on web, because a shear stiffener will be embedded around the web, right? And check on this web box and click this dot 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 box to define the which shape, which transverse stiffener shape are you going to use. So here, if you want to use a flat, you can just tell the program I'm going to use a flat. And the transverse stiffener, as I mentioned before, you can define it just one stiffener or two stiffeners. So if you want to make it two stiffener, just check on the select these two stiffener, and you can find the FY. This one is as you can see on here. Once you click the dot 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 box, among the our like library, you can find the steel like material properties on here. And pitch is a spacing between the web, between the like a transverse stiffener, and a B is base for the steel transverse stiffener sections, and T is the like a thickness of the transverse stiffener. Next one is shear connectors. So in order to have a perfect like a composite sections, you might want to put the shear connectors. So here is this picture is examples. This one has three shear connectors in a law, and this one is from the Midas Civil Design Guidebook. As you can see on here, the pitch is just the spacing between the shear connectors along with the longitudinal directions, and you can tell the program how many number of shear connectors are you going to use in a law. And you can also tell the program what is the spacing between the shear connectors with the transverse directions. And also you have to tell the program what is the height of the shear connectors and diameter, and what is the strength of the shear connectors. So let me switch it to the Midas Civil on here. So under like a design check, you can find the shear connectors on here. So click these shear connectors, and as you can see on here, you have the different categories, and you have to select it among those options. And the pitch, you're gonna, the spacing between the shear connectors, and the height, tell the program what is the height of the shear connectors. And also you can see the feet, this length unit, right? But if you want to use it as an inch, you can just instantly change the length unit as inch on here. And what is the diameter of the shear connectors, and what is the strength of the shear connectors. And you have to tell the program deck overhang load. So this F, the capital F, represent the distributed force. As you refer to these pictures, you can see those two F force create a moment. So you can tell the program what is the F, and the Midas Civil automatically calculate the moment for you. And the P is like a concentrated force. And also you have to tell the program what is the eccentricity of overhang load. And you can see the angle alpha on here, but as you can see, like a web height is already you already defined in the section properties. And if you just tell the program what is the eccentricity of the overhang, Midas Civil automatically calculate those angle alpha, and those one will be applied to get the F1, which is F times tangent alpha, and a P1 equals P times tangent alpha, and those calculation will be done by Midas Civil. So deck overhang load, you have to tell the program what is the distributed force and concentrated force, and what is the eccentricity of the overhang load. So once you go to deck overhang load, you can find the distributed force and concentrated force, and what is eccentricity of the overhang load. Other calculation will be done by Midas Civil. And then I want to talk about what is the design check output. First, you can get the big pictures. You can get the ideas span by span. So as you can see on this span results graph, you can see the demand versus capacity graph. So this green line represent the capacity, and the red line represent the demand. So you can get the where which location cannot satisfy the design AASHTO LLFD provisions. You can check your design check values under a span result graph. And also, if you want to see the more specific numbers, you can go to result tables. And also here we provide a strength, serviceability, and constructability, and fatigue limit. So those tables are provided for you to see more details. And then you might find some like red letters on here, which means it is not good. It is not satisfied with AASHTO LLFD. So in that case, if you want to see more detailed information such as equations and why this one is not good, you can extract a design Excel report. So let me switch to the MIDA Civil on here. So beforehand, you also have to tell the program what is the gutter sections, what element is under gutter sections, which is possible in the design position on here. Once you click this one and go to Group tab and double click the gutter, and you have to click the Apply on here. Because by define the design positions, MIDA Civil will recognize, oh, you're gonna do the like gutter sections design check on here. So don't forget to define the design position on here. Again, go to Tree menu and go to Group tab and double click the gutter icon. You can select the whole gutter element, and then you can click Apply on here. So as I mentioned before, you can check your demand versus capacity graph in the MIDA Civil. So this one shows like a strength, flexure, positive and negative moment, and you can also check the shear on here. So again, this green line represent the like capacity, and the red line represent the demand. Also, you can check your design output with the tabular information on here. So let's just go over the strength limit state on here in terms of flexure. Click this one. So you can see the like like a red letters on here, right? And it says NG, which is not good, right? In that case, if you want to see more detailed informations, you can go to Excel report. Once you click this one, you're gonna get the Excel report output. So beforehand, you have to tell the program which element are you gonna you have interest on extracting the Excel report. So go to position for design output, and just okay. Let's say if you have the if you want to extract the design Excel report in terms of element number 437, you can just enter the 437 on this table, or you can just go to model view and enter the 437 on the element box and click enter. And you can see the red highlighted line on here, and click apply. Once you click apply on here, you tell the program, I'm going to extract the design Excel report in terms of element number 437. So you can find the Excel report icon on here. Click this one and save as. And you're going to tell the program which unit system are you going to use, US or SI unit. I'm going to use a US unit on here. So it takes a little bit time. So while generating Excel report, I will just do the Q&A. So what are the steel beam elements by steel rigid beam or shell element? Oh, so this model is done by a beam element only. So still in Mitre Civil, we don't provide a design check for the shell element. So I got one more question. What are the difference between the negative and positive composite sections? So as I mentioned before, the composite sections for section negative is I just assumed the like like a section negative section is under negative moment, and positive section positive is under positive moment. So as you can see on here, here is a design Excel report. So you can see the basic like the parameters, I mean the basic information about the like the section properties on here. And once you go down, and you can find the equations on here, and this one says okay because it is satisfied with a design code. And you can see here is NG, which means not good. This one does not satisfied with the design, AASHTO LLFD12, so that's why it has NG on here. So you can see more like detailed information when you're extracting design, I mean the Excel report under like a design check. So what we have left is we have to cover the load rating part, but let me go to like a rating parameters definitions on here. As you can see on here, the is the almost same as the design check parameters, such as longitudinal reinforcement and transverse stiffener and umbrace lengths and fatigue parameters and curved bridge informations. So those are, already you understand how to, define those parameters in Mitre Civils. But about the load rating, we have the rating group setting. Because rating, for the rating, you might have interest on the, girders, right? So check on this box. It is the same as the design position for the design check. So in like a design check, when you're doing the design positions in design check, you tell the program um, like tell the program I'm going to use the girder sections for design check, and this one is the same as the design in load rating case. It is a different name, but the process is the same. So you can see the bridge rating group setting. So you just check on the girder and click add, and you can see the girder sections are defined it and are used for the load rating practice. So and other another parameters you have to define for the load rating case is define rating case. So let me switch to the slide. So this one is a steel composite bridge, weighting factors equations on here. So as you can see on here, you can see the like a load factors on here. You can use a max or mean, or you can use a both of them. So those you can just refer to the like load factors on here. You can find this information in the design guidebooks. And if you wanna change those like load factors, you can do that on here. And also at the very bottom, you can see the evaluation live load models. So if you want to just go with a design live load, you can just check on this design live load selections. And if you want to do more deeper analysis, you can select the legal load and permit load. So let me switch to the Midas Civil one here. So as you can see here, once you click the DC after, and if you want to change the load cases, you can just select this drop box and tell the program DC after is for the like other load cases. But usually when you're create your bridge model through the widget, you don't really need to change those stuff. So again, this load case is for the when you're doing the when you create your bridge model manually, you have to tell the program what is the load cases in each case. So we provide a service limit state and strength limit state and a fatigue limit state. So check on this box. Select this service limit state and tell the program what moving load case are you going to use for the load rating case. Because design check practice, you're going to use your design trucks, but sometimes when you do the like load rating, you're going to use a permit trucks. So in that case, you have to create another moving load case, like case for the permit trucks, and then you have to select the proper moving load case for the load rating case for the load rating practice, and then again you have to tell the program what is when you're gonna use a design live load or legal load and permit load, and then click add at the very bottom, and Midas Civil automatically create a load rating factor case for you. And then it is the same as the design check. So you can click the perform rating design on here to run the analysis for the load rating analysis. And also you can see the like load rating Excel report. You can extract the load rating Excel report on here. I already made one load rating Excel report on here. Let me just open that up. And it is a different format with a design check, but the you can get more information by extracting load rating Excel report on here. So once you set up all the parameters for the design check and load ratings, you can easily review the your like a design check result and a load rating outputs by using the table informations. And if you want to see more details, you can extract the Excel report. So those are available in Midas Civil. So I know like a load rating part, I just cover a little bit, but the I think the load rating is the almost same as the design check, but I told you different like parameters to accomplish the load rating practice. So this is almost done for the training sessions. So I can see the some of the questions. Oh, again, right after this training session, I will shoot you an email for the 1 PDH credit certifications. So if you guys have some problem with opening up the PDF file, just let us know. And I know you guys have some of you guys have questions. I will just follow you up after these training sessions because we have only 5 minutes right now. It's very hard to answer all of the questions. So, but I will just follow you up. Just sending an email about your questions. Thank you so much, guys, and see you next years. Thank you.